This is Stefan Schmidt, Professor of Political Science and Coastal Zone Management. Marine debris seems like a sort of highly specialized, maybe narrow subfield of coastal zone management in general, or coastal policy, or even more largely marine ecology and coastal ecology. But let me try and convince you that debris, also what we call marine and coastal flotsam, is actually a huge central core component of the problems facing coastal zones and the problems facing policymakers who are interested in working on coastal zones. And I'm going to do it by way of two examples. First of all, Hurricane Sandy, which in the late fall, early winter of 2012 hit the northeast of the United States, was a devastating event. It came in with a combination of fronts that produced both high wind, rain, and especially tremendous amounts of storm surge. It was a full moon, and therefore the effects of tides, of course, are exaggerated and enhanced, and the combination of those things, as we all know, created real devastation in primarily New Jersey, in New York, putting lower Manhattan really underwater, flooding the subway system, destroying whole neighborhoods, creating conditions in which fires broke out and burned down neighborhoods as hurricane force winds whipped the flames from one building to another. It created damage inland as the storm moved off the coastal zone, destroyed electric power grids, brought down power poles, cut off electricity to people, and in general, essentially was a mega event. As I watched Hurricane Sandy's consequences unfolding, I was really struck by the amount of marine debris that was produced by that hurricane. Entire neighborhoods were flooded and ripped apart. Everything in the neighborhoods, automobiles, vehicles, snowblowers, lawnmowers, garden equipment, marinas, boats, boatyards, boardwalks, amusement parks, and of course manufacturing facilities along the coast in New Jersey and other places where there were some, were all essentially ripped apart. And as that happened, a massive amount of debris was produced, which spilled into the coast, spilled onto the beaches, and spilled into the ocean. And that, of course, was essentially a naturally occurring natural phenomenon that that produced this massive amounts of marine debris. You make a list, if you'd like. Take a piece of paper and write down all of the things that you don't want going into the coastal ecosystem, into marshes, into creeks, into streams, onto beaches, into sand dunes, and so on. And see how big your list is of things that we never would allow individuals to pour into these systems. And in fact, we have fines. We will send the environmental police or law enforcement after you if you dump, very often under normal conditions when there are no disasters, people will pour oil from changing oil in their vehicles into city drains on the sides of streets because they want to get rid of it. And of course, that's illegal. It gets into the water system. And more generally, if you have ever been in a city like Seattle, you'll see signs actually on the drain plates along streets that tell you that anything that you put in there is going to kill salmon, because they have a picture of a salmon on it. And there is an effort then to even keep runoff from the streets and runoff from parking lots from going into the ocean. And imagine what went into the ocean in these northeastern coastal states when this storm hit. Toxic pesticides, toxic herbicides that people use in their gardens, oil, gasoline, diesel fuel, vehicles that were submerged that certainly probably leaked a lot of the fluids in the vehicles, asbestos. Some of the houses along the shore were older houses and no doubt were filled with asbestos. That asbestos now has been essentially transported into the ocean as the massive flooding receded back from these neighborhoods and flowed like little rivers down streets into the ocean. You know that it took with it really a toxic cocktail of all of these things that I've just mentioned and many, many more. There were certainly heavy metals. There was all kinds of equipment, perhaps, electronic equipment and so on that has very dangerous material in it, all of which was now ripped apart, ground up, and poured into the ocean. So that's one example of marine debris and coastal debris that I think makes it very crystal clear to you how important a field the study of marine debris is. The second example from this week that I want to give you is from Japan. Now, you remember Japan was hit by a major tsunami. That tsunami damaged nuclear power plants. The nuclear power plants actually released a lot of radiation. There was a lot of radiation in the air. There was a lot of radiation in the water. And of course, if you can remember the images of the tremendous amount of destruction, entire neighborhoods, entire towns really sort of flooding down into the ocean with buildings and houses and vehicles and ships and other things just floating along where there were streets and parking lots and dry land. And all of that destruction, when the tsunami was over, left this debris field that is enormous. We know about the debris field, that some of which is floating out in the Pacific Ocean and going into the gyres that the currents in the Pacific Ocean. Will be talking more about gyres and those kinds of scientific phenomena and laboratories for studying marine debris at some other point. But today I wanted to talk about what the Japanese are having to do with all that debris that is just littering Fukushima area and the neighborhoods where the tsunami hit. They have taken and ground up a lot of it in huge machines into sort of piles and piles and piles of wood chips and other chipped material. They can't dispose of it. They just don't have enough room to dispose of it. So they're shipping a lot of it in container trucks to other prefectures, to other locations in Japan in order to dispose it in facilities at those locations. People are worried to death because they're worried that material coming from an area where there was a lot of nuclear radiation are worried about it, and they don't want it in their neighborhoods. They don't want it in their landfills. They don't want it in their towns. So the Japanese government is having to ship the stuff, put down tarps when it arrives, have citizen committees who are representing the community come, sort of 5 or 6 people, join the disposal unit, taking some of the material out very carefully and putting it in little piles on the tarp on the ground, and then giving everybody equipment to measure radiation and to try and determine whether that material, the debris, is safe or not for disposal. And that has to go on with each shipment because the communities are worried that one shipment might be clean and another one will be contaminated. So you can see the incredible importance in this particular case of coastal and marine environments when it comes to the issue of debris. And under much more normal circumstances, when there aren't gigantic disasters, we of course also have debris fields. Beach combing is essentially the art or the sport of going to a beach and finding all kinds of stuff. And we've been all on beaches. I've been on beaches in, for example, in Bonaire, off the coast of Venezuela. And on the side that faces Venezuela, the beaches are covered with every kind of marine debris that you can imagine, plastic and bottles and just anything that floats away from Venezuela and ends up on the beaches of Bonaire. So even under non-disastrous circumstances, marine debris and the disposal of it and the issue of how it's created, where it comes from, what kind of damage it does, is to me a huge field. And anyone who studies coastal zone management, anyone who manages any of these coastal areas of the world, and you can see behind me in this map how much of the world is actually coastal, ought to have a course on and be familiar with the issue of marine debris. So we'll be looking at much more of that. I just wanted to bring these two particular cases and examples to your attention.